Hello students, so the question is a GP consists of an even number of terms if the sum of all terms is 5 times the sum of the terms occupying the odd places. Find the common ratio of the GB. So as we know that GP is in the form A1, A2, A3 up to so on, then R is the common ratio. R will be equals to A2 upon A1 equals to A3 upon A2. Now, in this GP, we have been given that the number of terms are even. Number of terms are even. So, the terms may be in the form A1, A2, A3 up to A2n. Since there are even numbers, so we will take this term as 2 to nth. Now, number of terms will be equals to 2n in this GP. Now, the relation we have been given is that the sum of all the terms is 5 times the sum of the terms occupying the odd places. Now, first of all, we'll write the sum of all the terms in the GP. So, this will be A1 plus A2 plus A3 plus up to so on till A2n. This sum is equal to 5 times the sum of the terms occupying the odd places. Means the odd terms are A1, A3, A5, A7 up to so on. So this will be A1 plus A3 plus A5 plus A7 plus up to so on till A2n minus 1. Since A2n is the even term in the GP, so A2n minus 1 will be in the odd place. Now, let A be the first term, it is the first term, and D is equals to, this will be R. R the common ratio. R is the common ratio. So, we can write as A1 is what? A1 can be written as A plus A2 is AR plus A3 is AR square plus up to so on. A2n is what? A into R to the power 2n minus 1. As we know that the nth term, the general term of the GP is A into R to the power n minus 1. This is the general term. So, here the last term is AR 2n minus 1. Total number of terms are 2n. So, this term will become A into R to the power 2n minus 1. Now, this sum is equals to 5 times of A1 plus A3 plus A5 plus A7 up to so on. So, A1 is what? A. A3 is what? It is AR square plus A5 is what? It is AR to the power 4. A7 is AR to the power, this will be 6 plus, now this term is A2n minus 1 will be AR to the power 2n minus, this will be 2 here. Okay. Now, the common ratio here, the common ratio is R, but the common ratio in this GP, which is the sum of the odd places of terms. This is, in this, the common ratio is what? AR square upon A, which is equals to R square. Now, we also know that the sum of n terms in GP, sum of n terms in GP is given by A into 1 minus r to the power n, where n is the number of terms, upon 1 minus r. So we will use this formula in this equation. So now this will be a into 1 minus r upon 2, 1 minus r to the power n. N is the number of terms, and here in this GP the number of terms are 2n. So this will be 1 minus r equals to 5 times of. This will be a into 1 minus common ratio is what? R square to the power which terms? Number of terms. R square to the power total number of terms. If total number of terms are 2n, then the terms which are in GP for only odd number of places, then those terms will be n. Total terms will be n. So this will be upon 1 minus again the common ratio, which is r square. Now again solving this further, we will get a into 1 minus r to the power 2n upon 1 minus r is equals to 5a. 1 minus r to the power 2n upon. Now we can write this as 1 minus r square. This can be written as 1 square minus r square. So this is the formula of a square minus b square. So we can write this as 1 minus r into 1 plus r. Now see what is cancelling. 1 minus r, 1 minus r, 1 minus r to the power 2n, and here it is cancelled. Then a is cancelled. Now we get what? We get 1 is equals to 5 upon 1 plus r. Now solving it further, we get this implies 1 plus r is equals to 5, which means r is equals to 4. So we have found the common ratio, which is r is equals to 4. Thank you.